Can you hear me? Hello? Can you hear me? Hello? Hello, everyone. A very good evening to all. I once again
Good
welcome you all. Yes. So I once again welcome you all for the fifth interaction session on atomic and molecular physics course. Myself, Vivekananda Naik. I am a PhD research scholar in the Department of Energy Science and Engineering, Plasma Physics Laboratory, IIT Delhi. So today, since it's our fifth interaction session, today we will be solving a few problems that will be covering the topics that has been taught in the course Atomic and Molecular Physics. So talking about the subjects that were covered in this week's lecture, it was about fine structure of atomic spectra. Then discussions were also related to multi-electron atoms. And when you talk about multi-electron atoms, then you need to arrange those electrons because till now what we have studied in both theory and both Sommerfeld modifications also, all the assumption that were taken was all related to a single electron atom, like hydrogen atom or helium plus, lithium 2 plus, like that. So there were no consideration about multi-electron atoms. So when multi-electron atom came into picture, then we need to arrange those electrons to different energy levels. So in order to arrange those electrons, we should follow Pauli's exclusion principle and Abbas principle. So basically, Pauli's exclusion principle states that no two electrons in an atom can have all four quantum numbers equal. For example, if there are quantum numbers associated with electron, that is N, L, Ml, and Ms, that is spin. So no two electrons have all four quantum numbers equal. That's why when we arrange the electrons, then since electron have spin half, that is 1 by 2, so the possible values of ms are minus half and plus half. So we can arrange electron in one subcell. Maximum two electron can be placed, one with spin plus half, another with spin minus half. And also there were some discussions about X-ray production, like also in last class we have also solved a few problems related to the X-ray production. So we'll also solve a few problems related to the production of X-ray spectra. Now, if you talk about the fine structure, so generally in the hydrogen atomic model, that is gross structure of hydrogen atom, gross structure of hydrogen atom, we consider the total energy, that is the Hamiltonian, we can say it was kinetic energy plus potential energy. And we all know kinetic energy is p square by 2m, p square by 2m0, where m0 is a Coulombic force of interaction. So the potential energy arises from the Coulombic force of interaction, and that has the expression of k z square by r. Now, if we talk about the gross structure, we found that in case of hydrogen atomic spectra, we had different lines like Lyman, Balmer, Paschen, like that, and each line was also splitted into different lines. Like H, in case of Balmer lines, we have number of lines that corresponds to transition from higher orbits, like H alpha, H beta, H gamma, like that. However, it was found experimentally that some of the small lines that was of low intensity was also found in the structure of atom. So due to this structure, we called it as fine structure of atomic spectra, and the fine structure of atomic spectra that rises due to a number of reasons. So some of the reasons, the reasons are: one is relativistic correction, relativistic correction, and it was from the, if you are following the lectures, it was obtained that the modifications of the relativistic correction was dependent upon the atomic number, that is z to the power fourth. Now, if you talk about other modifications, then another modification was spin orbit interaction, spin orbit interaction, and then another was Darwin term. So if you write the total Hamiltonian, it will become H is equals to H0, that is the initial Hamiltonian containing potential energy and kinetic energy, then relativistic correction plus spin orbit correction, and then Darwin term. So this was the complete treatment for fine structural spectra. So in fine structural spectra, we also saw that the uh, correction of, sorry, if you talk about the total energy was independent of any other quantum numbers, and it was only depend upon n, that is 1 by n square. So this was the conclusion from the structures. Now, if you talk about the case of spin orbit interaction, that we have solved a few problems in the last class also, where we found that due to angular motion and due to orbital motion and spin motion of electrons, due to interaction between two angular momentums, that is orbital angular momentum and spin angular momentum, the additional energy term contribute to the splitting of spectral lines or splitting of energy levels. And due to the presence of these number of energy levels, we have different spectral lines according to the transition rule and all. Now, if we talk about the concepts of multi-electron atom, now in case of multi-electron atom, what happens? If you talk about the spin orbit interaction, in case of lighter atoms, in that case, um, spin orbit interaction plays an important role. However, in case of heavier atoms, residual interaction plays an important role. So all these things we will be studying in our upcoming lectures. Now, if you talk about the problems, so let's start with solving a few problems that will be uh, based on this week's lectures. Uh, so now this is question number one. I hope my screen is visible to everyone who is present here. The accelerating potential of the electrons in a typical television picture tube is 6.2 kilovolt. What is the minimum value of wavelength of the continuous X-ray produced when the electrons strike the inner surface of the tube? Options are: option A, 2 Armstrong, option B, 1.5 Armstrong, option C, 1 Armstrong, and option D, 0.5 Armstrong. So these are the four options, and the question says the accelerating potential of the electrons in a typical television picture. So in a typical television picture tube, the accelerating potential is 6.2 kilovolt. What is the what is the minimum value of wavelength of continuous X-ray? So we need to find what is the minimum value of wavelength of continuous X-ray produced when the electron strikes the inner surface of the tube. These are the four options. So I'll give you a few minutes to try this question, and then we will discuss a few things about X-ray production, and then we will continue to solve this problem. So if we discuss about how the X-rays are produced, so first let me add another slide and then we will continue. So if we talk about the production of X-rays, so generally X-rays have higher energies. So since we know the radiations that are coming from atom depends upon the transition of electrons, so you can think of the fact that since X-rays are of higher energies, so their spectra is related to the transition of electrons that are present innermost in the atoms, because when the electrons are present innermost in the atoms, due to their energies bound to the nucleus, when they become free due to the transition, there is higher energetic radiation that are being produced. So now if we talk about the production of X-rays, so uh, since we since we know the X-ray production related to the innermost electrons. So in order to remove the innermost electrons, we need to provide higher energies. So if you talk about the experimental setup for X-ray production, suppose this is a X-ray tube. So basically this is a little bit spherical. So here there is a filament and here there is a target. So this is a target and this is the filament. This is filament and this is target. So these two things are then biased to a very high potential, for example, 10 kilovolt or so, or more than 10 kilovolt, we can say. So what happens? So due to the voltage applied between the two electrodes, electrons get emitted due to thermionic emission from the filaments, and since the biasing is negative from this side and positive this side, so electron gets accelerated. So when the electron gets accelerated, they hit this target material and the X-ray spectra is produced, and that X-ray spectra correspond to the target material. So the X-ray spectra produced uh, is corresponding to the X-ray spectra of the target material. And if you talk about the general X-ray spectra, suppose uh, we take intensity on y-axis and wavelength on x-axis, we'll found that it does not start from lambda is equal to 0, because there is a minimum wavelength in X-ray spectrum, and then the spectra is like that. It is something like that. I mean, there are some peaks. It is not fully continuous. There are some peaks corresponding to some particular wavelengths, and this is called as lambda minimum. So the continuous portion of this curve is called as background X-ray, and this peak is called as characteristics X-ray. Basically, the background X-ray that corresponds to the deceleration of electrons due to Bremsstrahlung scattering, because we know as a charged particle travels in a field region, its energy gets reduced, or it gets deaccelerated, and that energy comes out in terms of radiation. And if you talk about the characteristics X-ray depends upon the transition of electrons, and that transition of electron takes place when suppose one electron that is moving towards a target, it hits the innermost electron, then the innermost electron absorbs the energy from the incoming electron from the filament, and then that electron gets transition from the initial state to um, outside the atom, that so the two electrons are basically emitted, and to fill that spot, another electron from the next higher orbit comes back to fill its spot. So if you talk about, suppose this is N, this is K, L, M, N like that. So from L to K, M to K, N to K like that. So these line are called as K alpha, K beta, K gamma. Similarly, from M to L, N to like that. So it is just L alpha, L beta, like that. So these are different spectra or different components of an X spectra. Now coming to our question, the question says the accelerating potential of the electron in a typical television picture is 6.2 kb. What is the minimum value of wavelength of the continuous X-rays produced when the electron strike the innermost surface of the tube? Now, when the electrons strike the innermost surface of the tube, we assume that the energy that electron is carrying, that energy is completely converted to the radiation because the electron transfers its energy and that energy difference is liberated in terms of radiation. Now, if you talk about the energy, we know the kinetic energy is equals to half m vi square. And when the electron strike the inner surface of the tube, suppose that electron transfers its kinetic energy completely, so it will be equal to the electron volt energy, where V0 is the voltage difference across which it's being accelerated, that is 6.2 kilovolt or 6.2 into 10 to the power 3 volt. Now, this energy is equivalent to the radiation. So, this energy EV0 is equivalent to the radiation h nu or hc by lambda minimum. Now, if you talk about calculating the value of lambda, then the value of lambda uh, can be calculated if you put all the constant, because we know c is the speed of light in vacuum, that is 3 into 10 to the power 8 meter per second, and h is the Planck's constant 6.64 into 10 to the power minus 27 joule into second, like so. This is 12,400 by V Armstrong, where V is in volt. Now, if we put the value, so lambda minimum will be 12,400 divided by 6.2 kV, that is 6.2 into 10 to the power 3 Armstrong. So it is 12,400 divided by 6,200. So it is 2 Armstrong. So the minimum wavelength of the X-ray spectra is 2 Armstrong. So the correct option will be option A. I hope this is clear to everyone. Now, if we move to our next question, the question says an electron in an atom has orbital angular momentum L1 with quantum number L1 equal to 1, and the second electron has an orbital angular momentum L2 with quantum number L2 equals to 2. Now, what are the possible values of quantum numbers for the total orbital angular momentum L, that is equals to L1 plus L2? Options are 3, option B 1 and 2, option C 1, 2 and 3, and option D 0, 1 and 2. So these are the four options. I request you to try this question and then we will discuss after a few minutes. Yes, so can anyone tell me what will be the correct option?
Option D, sir.
Sorry, once again.
Option D, sir. D.
No, I don't think option D will be the correct option. Anyone other?
A, sir. A. Option A.
No, no, here the question says what are the possible values of quantum numbers? So, in general, what happens since you see these are vectors, orbital angular momentum L1 means L1 vector, L2 vector. So, when we talk about the vector addition, so since these are vectors, so we will follow here vector additions. So, according to the rule of vector additions, if there are two orbital angular momentum vectors like L1 and L2. Suppose L1 is 1 and L2 is 2. So uh, the total orbital angular momentum quantum number that will be L1 plus L2 up to L1 minus L2 mod with 1 increment. So this you should remember always. So if you talk about the vector additions, then it is L1 plus L2 to L1 minus L2 with one with a decrease of step one, or if you talk about the reverse case with L1 minus L2 mod, and with one increment it goes up to L1 plus L2. So now if we talk about, sorry, yes. So I
No, sir. No,
request
sir. I'm
everyone if they are okay. So I request everyone if they are not discussing with me, they should mute themselves. So it will be better for the
okay, sir.
whole environment. So if we talk
Okay, sir.
about the current question, so one is L1 is 1 and L2 is 2. So if you follow the same principle, 2 plus 1 is 3, then 2 minus 1 is 1. So we will start from 3 and then we go up to 1 by decreasing 1. So 3, 2, 1. Or we can write 1, 2, 3. So the correct option is option C. 1, 2, and 3. Similarly, for example, can anyone tell me suppose L1 is 5 and L2 is 5. Then what will be the total orbital angular momentum L, that is L1 plus L2? What are the possible values of L?
Yes, sir.
Yes,
0 to 10.
exactly. So 5 minus 5 up to 5 plus 5. So 5 minus 5 is 0, 5 plus 5 is 10. So it's 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So these are the 10 values of L. So why we are getting this? Because if we talk about vector addition, so if two vectors are aligned along same direction, then they will contribute to towards maximum. So then it is 5 plus 5. And then if two vectors are being aligned in opposite direction, then they will contribute to the minimum value, that is 5 minus 5, and in between these two values there can be any alignments. So corresponding to those values, since L can't be a integer, L can only be a whole number. So it can be an rational number, it can be only integers, positive integers. So it will be always positive, because since we are talking about the values, the direction can be different but values will be always positive. So for opposite case it will be 0, and for um, along the same, if they are along the same direction, then it will be 10. So starting from 0 we will go up to 10. So the possible combinations of the total angular momentum is this. So now you see in the question it says these L1 L2 are bold, so here L is also bold. So this L means L vector. So L vector has the values corresponding to 0, sorry, it is 1, 2, and 3. So since we are talking about vector additions, the additions will be such that to start from L1 minus L2 mod, and it goes up to L1 plus L2 mod with one increment. Now, is this clear to everyone?
Yes, sir.
Yes, sir.
Okay,
Yes,
so
sir.
we, we will move to the third question. The question says the magnitude of orbital angular momentum for an electron with orbital quantum number 3 is. Options are option A, root 3h, option B, 2 root 10h, option C, root 3h by pi, or option D, pi h by 3. So these are the four options. So can anyone tell me what will be the correct option? Yes, can anyone tell me what will be the magnitude of orbital angular momentum if an electron has orbital quantum number 3? So actually these things are related to quantum mechanics. So does anyone of you know about eigenvalues, eigenvector and all? Yes. So basically, so there is a equation. If we solve that equation, then we get the solutions of that equation. And there are certain conditions when we told that these values or the solutions are eigenvalues. So in quantum mechanics, what happens? So since in classical mechanics we define physical quantities, however in quantum mechanics all physical quantities are expressed in terms of operators. So when an operator, say, so for example in classical mechanics we have states. However, in quantum mechanics, we have quantum states, and that quantum state is defined in terms of or are expressed in terms of wave functions. So when we operate an operator on a state, and if we are again getting the same solution with a value, that value is called as eigen value. It is called as, suppose a cap psi is equals to a psi, then a is the eigen value and psi is the eigen function. Like that. So if we solve the equation corresponding to the orbital angular momentum, we get some values. So the solutions, this value in case of orbital angular momentum, suppose we operate orbital angular momentum. Suppose this vector is nothing but L. A, a cap is replaced by L cap, where L cap is the orbital angular momentum operator. So when it is being operated on a state with function psi, then it gives some value and it again generates the same wave function. So for this particular L, the eigenvalue is given by L into L plus 1 root over H cross. Since you see A is the operator, so since L is the operator, so its eigenvalue should be having same unit. And we know H cross has the unit of angular momentum, so its solution is, its value is L into L plus 1 H cross. Now the question says the orbital angular momentum quantum number is L equal to 3. So L is 3 and we know the value of orbital angular orbital angular momentum will be L into L plus 1 root over H cross. It will be 3 into 3 plus 1 root over H cross, 3 into 4 root over H cross, that is root 12 H cross. Or if you root 12 means it is 2 root 3. So 2 root 3 into H cross is H by 2 pi. So 2 gets cancelled out. It is root 3 by pi H or root 3 H by pi. So this is pi. So root 3 H by pi is the correct answer. So the correct option is option C, root 3 H by pi. So is this clear? So now for the present problem, you just remember, since the angular, if L is the quantum number given, its orbital angular momentum will be L into L plus 1 h cross. How these things are being calculated, that we will discuss when we talk about quantum mechanical treatment of hydrogen atoms. That anyway, we are going to discuss in a few weeks. So we will discuss all the things there only. So is this clear to you?
Yes, sir.
Okay, so then we move to the fourth question. The question says the potential energy of an orbital magnetic moment in a magnetic field B vector becomes minimum when the angle between mu vector and B vector is, options are option A 0 degree, option B 60 degree, option C 90 degree, and option D 180 degree. The potential energy of an orbital magnetic moment in a magnetic field B will become minimum when the angle between mu and B is, the options are A, B, C, D. So can anyone tell me what will be the correct option?
Sir, 60 degree.
No. So how you calculated it is 60 degree? So actually what happens when a magnetic dipole, we know each magnetic dipole has a magnetic moment. So when a magnetic dipole is placed in a magnetic field, it experiences some force because due to the uh, so it experiences some force, and since magnetic dipole consists of two equal and opposite poles, then they experience force with opposite magnitude, but they are acting along the same line. So if you talk about two forces acting along the same line of action, then uh, torque comes into picture. And due to this torque, the force experienced by the dipole, the due to that torque, there must be some energy that has been utilized. So if you if you talk about that energy, so the expression for potential energy of an orbital magnetic moment in a magnetic field is given by U is minus mu vector dot B vector. So why minus sign is coming here? The minus sign is coming here because it indicates that the potential energy decreases when the magnetic moment aligns with the magnetic field. So if we talk about the expression, we know in case of dot product, the expression is mu b cos theta. So u is minus mu b cos theta. So can anyone tell me now when there will be minimum energy? When there will be minimum energy? So u minimum means the value of cos theta should be minimum, is not it? So for what angle the value of cos theta is minimum? Sorry. mm, uh, so since it is negative sign here, so it is minus cos theta minimum. So it is cos theta should be maximum. So for what value of angle cos theta has maximum value? Yes. Yes. So the maximum value of cos theta is 1 and it corresponds to cos 0 degree. So cos 0 degree means the when the angle between mu vector and b vector is 0 degree, then the potential energy is minimum. Can anyone tell me what it does? It basically mean in physical sense. We solved it numerically. That is, since it is a dot product, and dot product means cos theta should be coming to picture, and since cos theta should be maximum because the negative sign is here, so the minimum value corresponds to theta is equals to 0 degree. But can anyone explain me in physical sense? So basically, the energy is being utilized to align the magnetic dipole along the magnetic field. So when the magnetic dipole is already aligned along the magnetic field, there no need. So we don't need to do any work. That's why the potential energy should be minimum. Since work done is minimum, potential energy is minimum. That's why when the angle between mu vector and v vector is 0 degree, then under that condition we get the potential energy is zero. Because again, if we talk about the maximum value, if the magnetic moment is anti-parallel to the external magnetic field, then the potential energy is large. But if the magnetic moment, when it is parallel to the field, then the potential energy is small because the work is done on the, and we talk about the so all these things we are talking about basically hydrogen atom or the electron present in hydrogen atom. The motion of electron in an orbital is such that it resembles like a magnetic dipole. So all these things we are studying related to the hydrogen atom treatment. So the work done on the hydrogen atom to rotate the atom's magnetic moment vector in the direction of the external magnetic field is therefore associated with a drop in potential energy. The energy of the system then is so is this clear to everyone?
Yes, sir.
So when
Yes, sir.
the angle between mu vector and b vector is 0 degree, that is they are being aligned because that when the when a magnetic dipole is placed in a magnetic field, it experiences some torque because, for example, same is for electric dipole also. So suppose there is a dipole. Suppose dipole means two equal and opposite charges. Suppose there is a electric field here and a dipole is present here. Dipole means two equal and opposite charges. Suppose this is minus q charge, this is plus q charge. So what will happen here? So this charge plus q, since the electric field is along this direction, this plus q charge will be getting repelled and this minus q charge will be getting attracted. So since they have a common line of action, so they will rotate. So it will move in this direction and it will move in this direction. So that rotation is due to torque. So due to when a force is applied along and a so a force is applied, if force into perpendicular distance gives torque, and due to that torque it moves. And why it moves? Because the tendency of the magnetic field is to align the dipole along the magnetic field. So in order to align that dipole along the magnetic field, it need to do some work, and that work is called as potential energy. That work is expressed in terms of potential energy because we know why work is equivalent to energy. So the expression is minus mu vector dot b vector. Also, your negative sign, what negative sign basically says? It says the potential energy decreases when the magnetic moment aligns with the magnetic field. So when the magnetic moment gets aligned to the magnetic field, potential energy decreases. That's why the expression is minus mu vector dot b vector. And when cos theta is zero, cos theta is zero, then the value of cos theta is maximum, that is one. So u is minus mu b cos theta, and that will become minimum when theta is 0 degree. I hope this is clear to everyone. Now we will move to our next question, question number 5. Question number 5 says the ground state of chlorine, the ground state of chlorine is 2p3 by 2. Find its magnetic moment in terms of mu b, where mu b is Bohr magnetron. The options are option A, 2 mu b, option B, root 2 mu b, option C, 20 by 3, root over of 20 by 3 mu b, and option D, mu b by 3. So can anyone tell me what is the value of Bohr magnetron? So the value of Bohr magnetron is 9.274 into 10 to the power minus 24 joule per Tesla. So now if we talk about the expression for finding out the magnetic moment. So we discussed mu L vector is minus GL mu B by H cross L vector, where GL was the uh, GL was 1 for orbital motion and 2 for spin motion, which is called as Landé G factor. So if you talk about Bohr magneton, we know we Since it is the total component, we can calculate the z component. The z component is given by minus gl mu b by h cross lz. And if we talk about in terms of quantum mechanics, we have lz is ml h cross. Similarly, sz is ms h cross. Suppose consider one electron is is present in s orbital. So can anyone tell me for s orbital what is the value of L?
Sir,
Yes,
0.
exactly. So since L equals to 0 because s orbital is spherically symmetric, so L equal to 0. So since L equal to 0, will there be any magnetic moment? Will there be any orbital magnetic moment? No. There will be or orbital magnetic moment will be 0 because L equal to 0. But if you talk about s orbital, we have spin magnetic moment because for s orbital, spin is always half for electron, is not it?
Yes, sir.
So if we talk, so can anyone tell me Bohr magneton? What is the expression for Bohr magneton? So the expression for Bohr magneton is nothing but E h cross by 2m. So how we will get that value? So if you calculate the z component of spin magnetic moment, so we know this is for g factor is 2 for spin motion, so it is 2 into e by 2m. E by 2m is the gyromagnetic ratio into ms h cross. So ms is, so since the s is half, so ms can be minus half or plus half. So you can so if you take half here, it is 2 into e by 2m into half into h cross. So half or 2 get cancelled out. It is e h cross by 2m. So e h cross by 2m is nothing but Bohr magnetron. So Bohr magnetron is the z component of spin magnetic moment of an electron present in s orbital. Is this clear?
Yes, sir.
Yes, sir.
So it also Bohr magnetron is basically the measurement unit of atomic orbital moment, atomic magnetic moments. So atomic magnet means it can be orbital magnetic moment or it can be spin magnetic moment. So if you talk about the quantification of the physical significance, the Bohr magneton is the value of spin magnetic moment of an electron that is present in s orbital. I hope this is clear. Now coming to our question, it says the ground state of chlorine is 2p3 by 2. Find its orbital magnetic moment. So we will again use that same formula that we calculated here, mu L equal to minus GL mu B by H cross L vector. So if you are using that formula, so what will be the value of mu L? So here the question says find its magnetic moment. So since here J is present, that is 3 by 2. So we will find the total magnetic moment. So the total magnetic moment will be mu j. Mu j will be gj into mu b. What was the formula? Gj into mu b by h cross, mu b by h cross j vector, or minus you can say. Is this clear to everyone? So mu j will be minus gj into mu b by h cross j vector. Is this clear?
Yes, sir.
Okay, so then we don't know the value of gz because we had the values of gl is 1 and gs is 2, but we don't have the values of gj because that will vary. The Landau g factor will vary for different orbitals or different levels. So we will first calculate gj and then we will put the values in that particular equation. Equation 1 we can name it. So what is the value of Gj? Gj is the Landau factor. If you remember in previous week's lecture, we had solved the value of Landau factor for a particular level. So it is 1 plus j into j plus 1 minus l into l plus 1 plus s into s plus 1 divided by 2 j into j plus 1. So the label we are calculating, it is 2p 3 by 2. So 2p 3 by 2. So can anyone tell me what are the value of s? What is the value of s? What is the value of l? And what is the value of j for 2p 3 by 2? Yes. So what are the values of S, L, and J for 2p3 by 2 level or 2p3 by 2 tall?
Sir, L1.
Yes. So L will be 1 because it is P. Then what is J?
S, S will be half.
S will be half exactly. Then what is the value of J?
By 2, sir. 3 by 2.
Uh,
Exactly.
plus
So J is 3 by 2. So our notation is 2S plus 1 LJ. L, since P, here L is P, we know S P D F. For S, P, for S, L is 0. For P, S is 1. Sorry, L is 1. For D, L is 2, like that. And J is 3 by 2 pressure here. And this 2S plus 1 is known as multiplicity. So 2S plus 1 is 2 here. Then 2S is 1 and S is half. So if we put these values of S, L and J, what we will get? 1 plus J into J plus 1, 3 by 2 into 3 by 2 plus 1, 3 by 2 into 5 by 2, which will be 15 by 4 minus L into L plus 1 into 2 plus S into S plus 1 by 2 into 3 by 2 divided by 2 into J into J plus 1. J is 3 by 2 into J plus 1 is 5 by 2. So if you calculate it, okay, let me add another slide. So if you calculate, Gj will be 1 plus 15 by 4 minus 2 plus 3 by 4 divided by 15 by 2. It will be 1 plus 1 by 3, that is 4 by 3. So the value of Gj is 4 by 3. So mu j is 4 by 3 mu b by h cross into j vector. So and j vector, the value of j vector will be j into j plus 1 root over h cross. Like the value of L vector was L into L plus 1 root over h cross, and the value of S vector was S into S plus 1 root over h cross. So these are the quantum mechanical notations or quantum mechanical treatments. It is 4 by 3 mu b by h cross into j into j plus 1 root over h cross. So h cross gets cancelled out. It will be 4 by 3 mu b into 3 by 2 into 5 by 2 root over. So it is 4 by 3 into mu b into root 15 by 2. So 2 gets cancelled out. It will be 2 by 3 root 15 into mu b, or 2 by 3 root 15 means, let me add another slide. So mu j will be 2 by 3 root 15 mu b. So it is 4 into 15 root over by 3 mu b, or we can say 4 into 15 by 9 whole root over into mu b. So 15 5, this is 3. So it is 20 by 3 root over mu b. So mu j is 20 by 3 root over into mu b. Is this clear to everyone? Correct option is option C, root over of 20 by 3 mu b.
Yes, sir.
Is this clear? So these type of questions you will get in your exam. So the basically the formula is mu L is minus GL mu B by H cross L vector. Here negative sign arises because the charge of electron is negative, and the motion of electron of the angular momentum that comes due to the motion of electron is going to opposes the motion. That's why the value is negative here. However, if you to calculate the total angular momentum, the expression is mu j is minus gj, or will be gj mu b by h cross j vector. Then gj, if you calculate the Lambda g factor value is 1 plus j into j plus 1 minus l into l plus 1 plus s into n plus 1 divided by 2 j into j plus 1. So the value of gj comes out to be 4 by 3, and if you put all those values, the value of magnetic total magnetic moment is 20 by 3 root over into mu b. Now coming to question number 6. Question number 6 says the spin orbit effects split the 3p to 3s transition into two lines such that 5890 Armstrong corresponding to 2p3 by 2 to 2s half, and 5896 Armstrong corresponding to 2p 1 by 2 to 2s 1 by 2. Calculate by using these wavelengths the effective magnetic field experienced by the outer electron in the sodium atom as a result of its orbital motion. These are the options. Option A 10.6 Tesla, option B 36.6 Tesla, option C 9.23 Tesla, and option D 3.12 Tesla. So now you see, initially it was 3p to 3s. Suppose this was p level and this was s level. However, if you see, for p level, we know s is half for both the cases, but for p, the value of L is 1, and for s, the value of p is and for s, the value of L is 0. So since for p, L is 1, so L plus s gives us 1 by 2 and 3 by 2, because L is 1, s is half. According to vector addition, it will be 1 plus half, 1 minus half. So already there is one increment, so we don't need to need other value. So it is 3 by 2 and 1 by 2. So this level gets split into 2p3 by 2 to p half. However, since s is have L0 and S is equal to half. So J will be only 0 plus half, that is half. It will be 2S half. So since then the transition will be from 3 by 2 to 2S half, and 1 by 2 to 2S half. So there are two transitions. So the question says the transition from 3 by 2 to 2S half, this transition is 5896 Armstrong, and this transition corresponds to wavelength 5, sorry, this is 5896, this is 5890 Armstrong. But we need to find out the effective magnetic field experienced by the outer electron. So how we will calculate? Yes, anyone? Can anyone tell me how we will calculate the magnetic field? So, see, initially when there was no spin orbit effect, there was a single line, but due to the spin orbit effect, the transition became two lines. One is 5890 Armstrong, another is 5896 Armstrong. So, what is the mean wavelength? So, the mean wavelength will be lambda 1 plus lambda 2 by 2, that is 5890 plus 5896 divided by 2, that is 5893 Armstrong. And what is the, if 5893 Armstrong is the mean, then what is the difference in wavelength? So it is 90, and then 96 is 93, so the difference is 3. So we know, if you talk about the frequency is nu is c by lambda. So the change in frequency will be minus c by lambda square delta lambda. And this change in frequency corresponds to the effect of magnetic field. And that, if you talk about the concept of Larmor precision, the frequency of precision was EB by 4 pi m. So these are the two equations. This is equation 2, this is equation 1. So when we equate these two equations, we can get the value of magnetic field. So here B is unknown. We know the value of, so we know the mass because mass is mass of electron. E is the charge of electron. C we know, C is the constant, that is 3 into 10 to the power 8 meter per second. And the value of lambda is known to us. So lambda will be 5893 Armstrong, and delta lambda will be 3, because in between the two splittings or the two levels the difference is 6, so the delta will be, so 3, that is 6 by 2. So if you solve this, is equals to c by, or b equals to c by lambda square 4 pi m divided by e into delta lambda. So c is 3 into 10 to the power 8 divided by lambda square. Lambda is 5893 into 10 to the power minus 10 square, 4 into 3.142 into 1.6 into 10 to the power minus 19. Sorry, it will not be 10 to the power minus 19. Here it should be the mass of electron, and the mass of electron is 9.1 into 10 to the power minus 31 divided by 1.6 into 10 to the power minus 19 into delta lambda. Delta lambda is 6. It is not 3, delta lambda is 6. Delta lambda is the difference between the two splittings, that is, the delta lambda is 6. It is delta lambda is lambda 2 minus lambda 1. That is 6 Armstrong. So 6 into 10 to the power minus 10 Armstrong. If you calculate it, it will give you 0.0 0.0000 366 into 10 to the power 6 Tesla, or 36.6 Tesla. So this is the correct answer, and the option is option B. So basically, this question says, what is the value of magnetic field due to which the spin orbit effect comes into picture and a single spectral line splits into two different spectral lines? So in order to have the value of the spectral lines, we need to determine the mean wavelength and the difference in the wavelength. So the mean wavelength was the mean of the two wavelengths, that is lambda 1 plus lambda 2 by 2, and the difference in wavelength was lambda 2 minus lambda 1, that is 6 angstrom. So if we put the formula, that is wavelength, frequency and velocity, so frequency nu is equal to c by lambda. So the change in frequency also is due to the magnetic field effect, because in Larmor precision we are studied also in case of G-man effect. If you have follow the lectures, the splitting depends upon the magnetic field strength, and that splitting in terms of the frequency is given by the formula delta nu is EB by 4 pi m. So EB by 4 pi m is equals to EB by 4 pi m is equals to C by lambda square delta lambda. So if you put all these values, only B is unknown here. So the value of B can be calculated from this particular expression. Okay, so we'll move to the next question. The question says, question number 7, it says, what is the magnitude of the orbital dipole moment mu of an electron in the hydrogen atom in the S state? Yes, I think this question everyone can answer. What is the magnitude of the orbital dipole moment mu of an electron in the hydrogen atom in S state? Yes, anyone?
Sir, D.
Option D. No. What is the expression for orbital magnetic moment, or orbital dipole magnetic moment? Mu L is minus GL mu B by H cross L vector, is not it? And the value of L vector is L into L plus 1 root over H cross. So what is the value
S
of
cross.
L? Sorry? What is the value of L?
0 for S.
Exactly. So the value of L is 0 for S orbital. So since the value of L is 0, the value of L vector is 0. And the total expression will become 0. So the mu L is 0 for S orbital. Is this clear?
Yes, sir.
Okay, so the correct option will be option A. Is this clear to everyone? Because the value of L is 0, the angular momentum of the angular value of angular momentum is L into L plus 1 root over X cross. Since L is 0, so L into L plus 1 root over will be 0, and the value of orbital magnetic moment will be 0. Now moving to question number 8. Question number 8 says, what is the magnitude of the orbital dipole magnetic moment mu of an electron in the hydrogen atom in D state? So the previous question was S state, it was in D state. So I hope you can solve it. So please solve it and tell me what is the correct option. After discussing all these problems, I can expect that you can solve this problem because same formula that we used in the previous question, this formula we will use there. Only the value of L will be different. And what is the value of L for D electron?
Two.
Yes, it is 2. So just put the value of L equal to 2 in that expression and tell me what will be the correct option. Yes. Did anyone calculate?
Sir, maybe C.
Maybe means you are not sure. Any other? Exactly, the correct option will be option C. So how we will calculate? So mu L is minus GL, or if you only calculate the magnitude, so it will be positive. GL is so GL mu B by H cross L vector, or GL mu B by H cross L into L plus 1 root over H cross. H cross gets cancelled out. The value of GL is 1. So 1 into mu B into L into L plus 1, that is 2 into 2 plus 1 root over. So 2 into 3 root over mu B, that is root 6 mu B. So the correct option will be option C. Is this clear?
Yes, sir.
Okay, so now again we move to the similar question. The question says, calculate the possible values of total angular momentum for a d electron in one electron atomic state. Options are option A, 15 by 2h cross, 35 by 2h cross. Option B, root 3 by 2h cross, root 5 by 2h cross. Option C, h cross 3h cross. Or option D, h cross root 3 by 2h cross. Yes, anyone? So here the question says calculate the possible values of total angular momentum. So we need to find the value of j vector, which is j into j plus 1 root over h cross. So for d electron, what is the value of L, what is the value of S, then and what is the value of J. So for d electron, and also question says one electron atomic state. So for one electron atomic state, the value of S will be half, and for d electron L is 2. So the value of J will be 2 minus half, 2 plus half. 2 minus half is 3 by 2, 2 plus half is 5 by 2. Is not it?
5/2.
So
Yes, sir.
since j has two values, so j vector will be again have two values. So for j equal to 3 by 2, j vector is 3 by 2 into 3 by 2 plus 1 root over h cross. And for j equal to 5 by 2, j vector will be 5 by 2 into 5 by 2 plus 1 root over h cross. So it is 3 by 2 into 5 by 2 root over h cross, that is 15 by 4 root over h cross, and this is 5 by 2 into 7 by 2 root over h cross, that is 35 by 4 root over h cross. So the correct option is root 15 by 2 h cross, root 35 by 2 h cross. So here root 4 is 2. So in the denominator it will be 2. So 35 by root 35 by 2 h cross and root 15 by 2 h cross. Is this clear to everyone?
Yes, sir.
Yes, sir.
Okay, so we'll move to the next question. That is question number 10. Question number 10 says calculate the wavelength of characteristics X-ray of K alpha line from the copper target, assuming Mossley's law, given the screening constant is 1 and the Rydberg's constant is 1.097 in 10 to the power 7 liter inverse. Options are option A 1.05 Armstrong, option B 1.83 Armstrong, option C 1.83 Armstrong. So at the beginning of the session, so we were discussing about the X spectra. So in X spectra, there are different components like K alpha, K beta, K gamma, L alpha, L beta, L gamma. So here question says the characteristics X-ray of K alpha line. So if you talk about the lines, this is K, L, M, N like that. So K alpha is L to K, K beta is M to K, K gamma is N to K. So this is K alpha, K beta, K gamma. So for K alpha, Ni is 1 and Nf is 2. And if
A4.
you, sorry, I could not hear you properly.
Sir, I was saying 2.
Once again.
Sir, I was saying 2.
Okay. Yes, so NF will be 2. So because the transition takes place, so this is the component we are interested in. So now, according to Moseley's law, so it is quite similar to the Bohr statement, but here there is a screening constant, additional screening constant that is due to the presence of other reluctance. Because when we talk about the innermost reluctance, the effect of the other reluctance should also be considered. In case of Bohr's theory, there are no multi-electron atoms, so there are no consideration about multi-electron atoms, so there was no screening effect due to presence of other electrons. The expression is 1 by lambda equals to r z minus 1 square 1 by ni square minus 1 by nf square. So can anyone tell me what will be the value of z here? R is known to us 1.097 into 10 to the power 7 meter inverse. And
Sir,
NINF I just
29.
mentioned in the. Yes, because we are talking about copper target. So for copper, the atomic number is 29. So R will be 1.097 into 10 to the power 7, 29 minus 1 square, 1 by 1 square minus 1 by 2 square. So if you solve it, it will be 1 minus 1 by 4 into 28 square into 1.097 into 10 to the power 7. So it is 3 by 4 into 28 square into 1.097 into 10 to the power 7. Calculate it. It will be, then lambda will be 1.55 into 10 to the power minus 10 meter or 1.55 Armstrong. Is this clear to everyone?
Yes, sir.
Yes, sir.
Okay, so due to the presence of other electrons, the screening constant was 1 because it is mentioned here. So in general, the expression is Z minus sigma square. So here sigma was 1, that is the screening constant. And the correct answer is 1.55 Armstrong. Now, if we move to the question number, if we move to question number 11, question number 11 is a type of is a is not a basically it is a different type of question. That is statement one is given, statement two is given. Now we need to find out whether the two statements are correct or whether the statement one or statement two is the correct explanation of statement one. The question says, the statement one says, if the accelerating potential in an X-ray tube is increased, the wavelength of the characteristics X-ray do not change. And options because statement 2 says when an electron beam strikes the target in an X-ray tube, part of the kinetic energy is converted into X-ray energy. So statement 1 says something, statement 2 says something, and we need to find out whether statement 1 is true, statement 2 is true, statement 2 is a correct explanation for statement 1. Both the statements are true, or statement 1 is true, statement 2 is false, statement 1 is false, statement 2 is true, or option B is statement 1 is true, statement 2 is true, but statement 2 is not a correct explanation for statement 1. So it says one thing and it explains the statement 1. So we need to find out whether the statement 2 is correct, statement 1 is correct or not, and whether statement 2 is the correct explanation of statement 1. And again, this question related to X-ray production.
Sir, according to me, it will be A.
So you are saying statement 2 is a correct explanation for statement 1.
Yes,
Okay,
sir.
so anyone other has any other options or any other answers? Yes, anyone other? So if you talk about the correctness of the two statements, so statement 1 says if the accelerating potential in an X-ray tube is increased, the wavelengths of the characteristics X-ray do not change. So can anyone tell me whether statement 1 is correct or not, or true or not?
Sir, once in Compton shift, we came to know that the light, the when an light get um, scattered with an electron, two components will be there. One will be having the change in wavelength, that is that wavelength will be very greater, that is the frequency is less, and the another one will be same as that of the incident ray. So
Exactly.
according to that, I think the statement 1 is correct. And based on that, the statement 2 will also correlate with the statement A, sir. So the option A will be
No, actually,
true. It
here,
seems to
no,
be.
what you said, no, what you said, that's correct. But here we are talking about the X-ray spectra. Compton effect, basically, Compton effect is the interaction of X-ray spectra with another electron. But here we are talking about the production of X-rays. So in production of X-ray, there is two electrodes. One is filament, when the from where the electron gets emitted, and there is a target, and the electron hit the target and the X-rays are generated. So, and X-ray, if you talk
Okay,
about
sir.
X-ray, if you talk about X-ray spectra, there are two components. One is characteristics X-ray, another is background X-ray. So the components we are talking about K alpha, K beta, K gamma, L alpha, L beta, L gamma. That components are of characteristics X-ray spectra. But actually, the X-ray spectra that we have discussed, it is something like that. So there are some peaks, which is characteristics lines, and these are background lines. And there is a minimum value. So the statement one that says if the accelerating potential in an X-ray tube be changed, the wavelength of the characteristic X-ray do not change. So this statement is true because if you see in this particular statement or in this particular problem, we calculated the wavelength of characteristic X-ray from copper target, and there was scattering constant and a reward constant. So here you see in this question there is so the characteristics X-rays are a characteristics feature of a particular element. That is, so when we are changing the accelerating potential, the X-ray wavelength will be the same. That will it not change. So statement one is true. And if you talk about statement two, when an electron beam strikes the target in an X-ray tube, part of the kinetic energy is converted into X-ray energy. That is called as Bremsstrahlung long radiation. Bremsstrahlung long radiation. So it is background X-ray. So it explains background X-ray. So these two statements are true, but statement two is not the correct explanation of statement one because statement one talks about characteristics X-ray. However, statement two talks about background X-ray. Is this clear to you?
Yes, sir.
Yes, sir.
Yes, sir.
Okay, so here the two statements are true, but statement two is not the correct explanation of statement one. So these are the questions that I wanted to discuss with you. So with this, we come to the end of today's interaction session. So in the next interaction session, we will solve a few problems that will be again covering the week 6 lectures of the course Atomic and Molecular Physics. So if you have any other doubts, you can ask me. I will try to clarify their doubts. Okay, so if there are no further doubts, we can stop today's session. Thank you. No, I again thank you all for joining in this session. Uh, that's it from my side.
Thank you.
Have a
Thank
great.
you, sir. Thank you
Thank
for
you.
guiding us, sir. Thank you for guiding.
Okay, well, welcome.
Thank you, sir.
Okay. Good night.
Good night, sir.
Thank you.